Hello everyone, my name is Vadini. I'm assistant professor in RPIIT Karnal, Haryana. Today we are going to learn about applications of data structure. First one is array. An array is a linear data structure that stores collection of elements of the same data type in a contiguous memory locations. Imagine a row of numbered boxes, each holding a single item. The boxes are arranged sequentially and you can access any box directly by its number or index. This makes array excellent for storing and accessing data in a fixed and ordered manner. Arrays are often used to store list of numbers or characters or other objects. They are very efficient for storing accessing sequentially data, but they can be less efficient if you need to insert or delete the element in the middle of the array. This is the representation basically. So in the memory, so this is RAM. Like this, we can 4 bytes we are storing. So this is the memory address. For example, like 100, 104, because 4 bytes we are using. So these are the locations where we are storing it. The second one is linked list. The linked list is a linear data structure where the elements are stored in a sequence of nodes, each containing a value and a pointer to the next node. Picture of the or a chain of boxes, connected boxes, each box holding a value and linked to the next one in a chain. This allows the list to grow or shrink dynamically as needed. Unlike arrays, linked lists don't have to store data in contiguous memory locations. They are very flexible and also allow for each insertion and deletion of elements at any locations or position, making them suitable for scenarios where the data type is unpredictable. However, accessing each element can be slower compared to arrays. So these are the representation. So here is the data and here is the pointer like of the address of the next array. So this address is will come here so that it is being linked. So in the doubly linked list, the header one, so it in this like easy to delete and insertion can be done. In the doubly linked list means we have both the addresses of the previous one and the next one. Next one is stacks. A stack is a linear data structure that follows the last in and first out principle. Imagine a stack of plates where you can only add or remove plates from the top. The last plate you add is the one you take off. Stacks are often used to implement function calls, undo, redo functions, and expression evaluations. So they are also used in memory management to keep track of the memory that is currently in use. They are efficient for adding and removing the elements, but accessing elements in the middle can be less efficient. So this is a stack which is given. The element which you are inserting is a push operation here, and the element which is being popped means it's been deleted, that is a pop operation. So here the first stack comes in the last. Matrix is an ordered collection of elements arranged in rows, columns, have broad applications, that is conducting seismic surveys in geology, plotting graphs, statistical analysis and scientific research representative representing the real world data like population demographics, supporting reflection and reflection studies in optics. So this is the structure of the matrix, like the rows and the columns are given here. So this is a matrix data structure. Next one is queues. Queue is a linear data structures that follows the first in first out. Like as you stand in the queue, when you come first you go out also, so it will be moved like that. Okay, so think a line, people waiting for a bus. The first at the front of the line is the first one to get on the bus. Queues are often used to manage tasks in a system such as processing requests or handling events. They are also used in buffering data where the data is stored temporarily before being processed. They excel at managing data in a sequential order with the efficient addition or removal of the first, and accessing even element can be less direct. So the process where the insertion being done, this operation in the queue, we call it NQ, and when it is deleted means when it's been deleted, element is being deleted, that means it's a DQ. Priority queue, it is an extension of the queue. Every element has a priority associated with it. An element with the high priority is GQ'd before an element with the low priority. If the two elements have the same priority, they occurred as like according to their order in the queue. Likewise, this is the high priority element. Let's say this is a queue and this is the high priority, so it will be DQ'd earlier. And NQ and DQ is the same operations which we used in the queue. Trees. This is a non-linear data structure, organizes data hierarchically, similar to the family tree. Each node in the tree can have multiple children, forming a branches structure. A tree has a root node at the top, and other all the nodes are connected to the roots and through the series of the branches. Often this is also represented like hierarchical representation such as file system or the organizational structures or decision trees. They are very efficient for searching and sorting data, especially if the data is already organized in the hierarchical manner. However, the managing of the complex tree structures can be com- computationally, it's very intensive. Graph. A graph is a data structure is used in a collection of data and the nodes connected by edges like that. So here like edges, these are edges and these are nodes. 2 is the node and it's connected with the edges to 6. So here a graph algorithms are methods to use the manipulate and analyze graphs, solving various problems like finding shortest path, detecting cycles, and these are the non-linear data structure consisting of the vertices and the edges. These are very powerful tools to represent and analyze the complex relationships between objects and entities. So they are particularly useful in the field of social network analysis, recommendation systems, and other computer networks. Hash table. A hash table is a data structure that is used as a hash function to map keys to indices in an array. The hash function takes a key as input and returns a unique index, allowing for fast access and retrieval of the data associated with that key. Hash tables are also very efficient for storing and retrieving data based on keys. They are commonly implemented like dictionaries, symbol tables, and database indexes. Their efficiency depends on the quality of the hash functions and collision of resolution and strategy employed. So this is the basic representation of the hash. Like these are the keys which is being like index, and the values are there in the form of here linked list. So heap data structure, it is a complete binary data structure that specifies the heap property for every node. The value of its children is greater than and equal to on value. Heaps are usually used to implement priority queues where the smallest or the largest element is always on the root of the tree. A heap is a binary tree based structure that follows the heap property. In a heap, every value, each node are compared to the value of its children in a specific way. Maximum heap and minimum heap, what are these? The value of the each in the max heap, for example this one, is each node is greater than or equal to the value of its children. So each node here, this is greater, 100 is greater than 40 and 50, 10 and 15 is greater than 40, 50 and 40 is greater than, almost it's equal. So like that. Minimum mean heat, that is the value of each node is less than or the value equal to its children. So 10 is less than 15 and 30. Root nodes contains the minimum value. As they move down, the value increases like this. So if you like the information, do like and subscribe our channel.